Welcome back. In this video we're going to look at creating our first program. So we're going to open up Notepad++. We're going to save a C file called helloworld.c to our lab0 directory that we created in the last video. Now this is mapped on Windows and Unix, so you can save it on Windows and it'll appear on the Unix. So at the start, what we're going to do is write a little bit of code. Now this little bit of code might seem like a lot, but we need all these basic things here just to start us off, and then we'll write even smaller amounts before we compile. So the first thing we're going to write is hash include standard input output.h. Okay, so we've got these triangular braces here. We've got stdio, which is standard input output.h, and then the closing triangular brace. This isn't studio, it's standard IO, okay, for standard input and output. Then we go down and write int, then main, and then two brackets. Then we put an opening brace, press enter a couple of times just to move down a little bit, and then a closing brace. Just before the closing brace, if we push up, we write return 0, semicolon. This is the standard template that you're going to work with at the start of nearly every week in this subject. And you need to get used to writing this, and this is the first thing that you check that works, because if this doesn't work, it's going to cause you headaches. So it is really, really important that you start this off and compile this once you've got this written. Now, one thing before we go and compile is what we'll notice is that we've got this indentation here. Okay, you'll notice that everywhere between these two braces is indented, and it's indented by one tab. And this is called Allman style, and this is the style that we expect you follow. It makes your code readable. Okay, imagine reading a book that's been written from the bottom of the page up. Okay, yes, you can read it, but it makes it extremely difficult. You need to follow this style. Now what's great is Notepad++ does this automatically for you if you let it. So if I put another brace, press enter, you'll notice that everything between these two braces is indented by another tab. This is the style that you're expected to follow. Now let's get rid of that. So at this point here, even though we haven't written much, even if this is the week 10 and we're super confident, we should still go and compile this. Okay, we need to follow what we had here. Okay, write a little bit of code, then compile. So before compiling, and a major mistake a lot of students make is they forget to save. So save your work. Okay, so I've just pressed Control S. Alternatively, you can come up here and press the save. From there, we can go into Unix. Now, we need to go into this directory, so that's inside of lab0. Okay, and we'll see our helloworld.c here. Now we're going to compile our code. So if this is all correct, then it will create an executable, which is a program that will actually run. So we're transferring this text into an actual program. Okay, so we're turning this text into an actual program. So now we need to go back here. So to do that, we type cc, which is the compiler. Then we need to add some options. So we're going to add the option -W ALL, which stands for warnings all. This will give us all of our warnings, and we'll talk about warnings shortly, because these are a little bit more complex than how we deal with errors, but they're easier than errors. Then from there, we're going to write minus O and then the executable name. So this is the program's name. So you can think of it like Photoshop, okay, that's the program's name. Microsoft Word, that's the program's name. The hello world.c is the source code or code's name. So what follows the minus O has to be the executable name. Now, if you accidentally write .c here, you've lost all your code, okay? Now, there are some tools that we can give you to avoid that, but basically here, if you do write .c, you've lost all your code because you're going to overwrite your source code with your executable. So keep in mind that these two work together. So you've got minus O, which says give me an output name, and I want the output name to be this. The output name doesn't have to be the same. We've got it the same here, but it could be something different, so you could have written hi world here instead, and that would have been perfectly fine. Then you've got your source file. This is the thing that the compiler is going to read and go, can I understand this? If I can understand this, I will turn it into this. So we press enter, and we don't see anything. And a lot of students go, oh, it didn't work. So when you don't see anything, that's a good thing. Okay? It means that there's no errors. And if we type ls, we can see this new file here, and this is our executable. And if we want to run this, we can type hello world without any extension and press enter, and it runs. However, if we go back here, it's not testable at this stage. So running it doesn't really do much, okay? So there's not much point running it because it's not testable yet, okay? It's not giving us any information, okay? We saw how much code's here. At the moment it could have 50,000 lines of code but no output, or it could just be as simple as this. We don't know, we can't test it. There's nothing coming out to us. So I want to go back here and introduce a mistake. Now every time we change our code, we need to resave it, go and compile it, and then we can go run it or fix it and so on. So I've made a change, okay? I'm going to go Control S to save. I'm going to go back in to Unix. I'm going to compile once again. It's now using the new version of hello world.c. We're going to overwrite our executable. We don't want a huge number of executables, so we'll just overwrite that, and we'll press enter. And we get this horrible looking error. Okay? Now, this, at this stage, shouldn't mean much to you. Okay? And it's going to be hard to read, and that's understandable. But we can look at some keywords here. And if we have a look at this here, we've got undefined reference to main. So this gives us a clue to where our mistake is, okay? And so we can go in and go, okay, our mistake probably has to do with something about main. Okay, I've spelled main incorrectly. Now, even if this error message was even more cryptic and you didn't understand what it meant, how many lines here have you got to choose from? 1, 2, 3. There's only 3 places that there could be mistakes. If this was 400,000 lines, there's no way you would find even the simplest mistake like this. And this is why following this is really, really important. The other thing is that you'll never make that mistake again because you've learned from it and you've reinforced your learning straight away. So we'll get rid of that and we'll save once again and then we'll compile. Now you might ask, why did I fixed the mistake, why did I go back and compile? Because I want to maintain working code. I want to try and maintain something that works constantly. So even though I know I fixed it, I need to double check. So now we're going to add the printf function, and you'll learn more about what this means later. But basically this will print text or numbers to the screen. So we write printf, we've got a bracket there, then we've got double quotes, and then we're just going to write hello world. And and then we've got the semicolon at the end. So I've got that. I've written one line of code. I'm going to save and compile it so that I can check, is this line correct? It might seem excessive that I'm compiling constantly, but it will make it so much easier later if you don't. I mean, if you don't, it'll make it so much harder. If you do, it'll make it so much easier. Alright, so we're going to save that. Control S, we'll go over and compile, and everything comes out perfectly fine. Now from here, I'm going to run it because it's now testable. And we notice that there's a problem. Okay, so we've got hello world, but then we don't get a new line after it. We've got this 113, which is actually just the number on the console. So we need to go back and fix this. Now, the type of error that this is a logic error. Okay, so the compiler said, yep, everything's fine, everything's beautiful. But it's not, because we've got a logic error. So we're going to go back in, and we're going to go after this hello world and add a /n. And that will add a new line to the end. So we go Control S, come back in, that's the wrong one, come back in, compile once again, run, and we get the correct output this time. From here, I can add another line. Okay, let's say I want to do hi world. Okay, and we've got that. I'll save that. I'll go compile that. I will go run that and test that it works, and it does. So at this stage, we've had a look at our errors, we've had a look at this workflow, and now we've got one more thing I want to show you. And this is warnings. So I'm going to write this here. So I'm going to write int a. Okay? So this is a variable. This is a place that we're going to store values in. It has a type, which we'll look at a bit later. But this here, we don't use it in the program. And the compiler's smart and knows that. So let's go back and compile this program. So here, we don't see any error, but we see this warning, okay? Unused variable A. Now, when you just have a warning, the program will still compile and run. Okay, so if I type hello world, it will still print hi world. What the compiler is saying is that you've done something silly, but maybe you did it intentionally, and we won't worry about it right now. At the end, when you finished your program, you should have no warnings. But while you're programming, it's likely that you're going to have a couple of warnings while you're working. But at the end, you should have no warnings. Alright, so that's it for this video. Thank you.